Okay, so here's the start of your week 4 ACT, and the passage that we're working on, the standard, is IOD 404. So this is a little bit different. It's not going to be reading, highlighting, whatever. It's going to be determining trends. So this one is where you have to extrapolate or interpolate. So your first steps always are going to be to read the question, find variable 1, determine the trend. Then you find variable 2 and you determine the trend. And then you take the number from the question and you find where it fits. And the last is you make your prediction. Okay, so let's go through these questions. Number 1. If the scientist measured an oil droplet with a radius of 0.62 micrometers, its weight would be the closest to which of the following? So we need to look for weight. That's one of ours. And then the first thing that we're looking at is radius. So that is, where are we going to look? If scientists measured an oil droplet, so it's not going to actually be that table. So we're going to go back to table 1. So I need to look at radius and then weight and see where these fit. So I'm going to determine the trend here. So what I'm going to do is put these in order because they're not in order. So you should always put them in order. So 0.574, 0.591, 0.645. And because the one we're looking for is right in here, 0.620, we don't need to go further than that. And then I'm going to go to the weight. So that's 7.38 times 10 to the negative 12. And then it's 8.058 times 10 to the negative 12. So these numbers are increasing. 1.048 times 10 to the negative 11. So that means my number is going to be in between these. So I need a number in between 8 times 10 to the negative 12 and 1 times 10 to the negative 11. And so which one of my answer choices are between those? 1 times 10 to the negative 12. Nope. That's too small. That's below the 8. And that is too big, so my answer is C. Number 2 says, the scientist measured an oil droplet with a charge of 19.3 times 10 to the negative 19. The normalized charge, so I'm looking here and here. All of these say 18, so the first thing I need to do is convert that. So that would be 1.93 times 10 to the negative 18. Now let's figure out where this falls on the table. The trend here, they're in order, and that's decreasing, so we're going to put it in between here. 1.93 times 10 to the negative 18, then I'm going to go over. That means my normalized charge is between these two values. My answer here is between 14 and 11. The answer is B, 12. Number 3. Based on the data in Table 1, an oil droplet with a mass of 2.783 times 10 to the negative 12. So the mass should have a volume of 2.783 mass. So again, I'm going to put these in order down here. So I'm going to do 2.461, and this is the one I'm looking for, right? And it's times 10 to the negative 12. So we're here, then 3.66 times 10 to the negative 12. I just need to look for the ones that's going to be in between. Then this one is I'm looking for volume. So that would be 2.591. And that would be 3.859. So I need a number between those two values because the first variable is between. So which one here is in between 2.5 and 3.8? And that's going to get us C. All right, based on Table 2, So we're looking at this page still, a normalized charge, so that's one of my variables, of 9, and then a charge of, so we're going to look at these here. So a normalized charge of 9, let's see where that would fall. So we have 8 and 10.1, so 9 would go right in between those. And then if I look over on the table, where do those line up? So that would be 1.62 times 10 to the negative 18 and 1.28 times 10 to the negative 18, and a number would be in between these two values. All right, now it wants to throw us off, so it gives us the answer in 10 to the 19, and that's why this is confusing. All you need to do is bring this decimal over 1 point. So we need between 1.2 and 1.6. And what do we have? 1.2, 1.6, that's going to be C, because that one is 1.4. So what this does actually require you to know science-wise is that you need to know your exponential notations. So those, and you need to know how these relate to each other. So 10 times 10 and then would be 1 times 10 and then negative 18. And that's something that you do need to know to answer these correctly. So that's why this one's difficult. All right, the last question, number 5. According to table 1, a particle with a volume of 3.52 should weigh approximately. So we're looking for volume in table 1 and weight, and we're looking at 3.52. So again, we pick the numbers that's going to be in between. So I have 3.52. Let's see, I have a 3.8 here, and that would be 3.596 times 10 to the negative 11. 3.52 is our target value. What would be right below that? So we're going to go 2.519 again, and that would be 2.414 times 10 to the negative 11. So my answer is we need to look for in between 2.4 and 3.59. So 2.4, 3.59, answer. That's too low, too low, too... Well, we have 2.6 and 3.2. So now we're between C and D, so which one would be the right answer? So let's go back to our table. Do we want it to be closer to 2.4, or do we want it to be closer to 3.59? 3.52 is way closer. So on the number line, the distance here between these values was 2.5, 3.5, 3.89. This distance was way shorter than this distance, so we want our answer to be closer to this number, so that's why the answer is D. But what that also means is your distractor is C. That's it for that one.